Hello everyone, welcome back. Today we will continue our machine learning journey with another video. This time we will focus on the supervised learning types. Last time we have discovered what learning is. Also, we saw what supervised and unsupervised learning are. You can check that video using the link above. Let us start. We called the supervised learning from our previous video. Remember that we have our data where x and y are present. As you know, y values are called the response or dependent variable and x are called independent variables. In supervised learning, our model uses y values for learning purposes. So the y values act as a teacher in this kind of learning problem. We are trying to fit a model that relates the dependent variable to the independent variables or predictors with the goal of accurately predicting the y values for our future observations or better understanding the relationship between the response and the predictors. Broadly speaking, supervised statistical learning involves building a statistical model for predicting or estimating an output based on one or more inputs. We train our model using response variables. In supervised machine learning models, the main goal is to predict y values correctly. Supervised learning algorithms can be divided into two categories, classification and regression algorithms. Both the algorithms are used for prediction in machine learning. They work with the labeled datasets, but the difference between both is how they are used for different machine learning problems. For the classification tasks, the output variables are often called labels or categories. The mapping function predicts the class or category for a given observation. So, classification algorithms are used to predict the discrete values such as male or female, true or false, spam or not spam, etc. Basically, you are doing a classification over a finite number of things. However, in regression algorithms, the output variable is a continuous real value, such as an integer or floating point value. These are often quantities such as amounts and sizes. Thus, regression algorithms are used to predict continuous values such as price, salary, age, etc. Let us have a close look at the classification algorithms. In classification, the output variable must be a discrete value, so that we can select or classify among the finite number of categories. In classification, we try to find the decision boundary, which can divide the dataset into different classes. The classification algorithms can be divided into binary classifiers and multi-class classifiers. In binary classification, you have only two categories as an output, like 0 or 1, or true and false. In multi-class classification, you have more than two categories as an output, like red, green, and blue. We can give an example for the binary classification problems. Suppose that you are a data scientist at Microsoft, and your manager asks you to come up with a machine learning algorithm that classifies emails as spam or not spam. Your algorithm should pay attention to various features of the incoming mails. Your training dataset would include two types of mails, spam and not spam. We can give an example for spam mails, which are the mails that are sent by companies for their ads. Also, the email that includes your credit card bills from your bank is an example of not spam emails. You want to classify the first one as spam and the second one as not spam. This is a binary classification task, since there are only two discrete classes. Thus, it is called binary classification. We can give an example for the multi-class classification problems. As said earlier, multi-class classification problems include more than two categories as an output. Thus, you need to classify them accordingly. Suppose that you are a data scientist at a journal, and you are required to create a machine learning algorithm for classifying news in different categories like politics, sports, or the economy. As you can see, There are multiple classes, namely more than 2 classes. Thus, binary classification would not work in this case. This is a multiple class classification task since there are more than 2 discrete classes. Thus, it is called multi-class classification. Let us have a close look at the regression algorithms. In regression, the output variable must be a continuous value so that we can find the best output values over continuous values. In regression, we try to find the best fitted line which can predict the points in the dataset over a line. There are many regression algorithms. However, some of them are simple regression and multivariate regression. In simple regression, you have only one input to predict the output value, whereas in multivariate regression, you have multiple inputs for predicting the output. We can give an example for the simple regression problems. Simple regression problems are problems where you have only one independent variable for predicting the dependent y variable. So the formula for this task is y equal to beta 0 plus beta 1x plus epsilon. Note that the term epsilon is the error term. There are many assumptions behind this relation. However, those are out of scope of this video. Predicting the marks of students based on the number of hours studied can be given as an example. In this case, we have the number of hours studied as an independent variable and marks as a dependent variable. We are going to use x to predict y by adjusting the beta variables in the formula presented. We can give an example for the multivariate regression problems. Multivariate regression problems are problems where you have more than one independent variable for predicting the dependent y variable. So the formula for this task is y equal to beta 0 plus beta 1x1 plus beta 2x2 plus till beta k xk plus epsilon. And here, the term epsilon is also the error term. And again, there are many assumptions behind this relation, and those are also out of the scope of this video. Predicting the marks of the students based on the number of hours studied and the marks on the older exams can be given as an example. In this case, we have number of hours studied and historical marks as independent variables and marks as a dependent variable. We are going to use x values to predict y by adjusting the beta variables in the formula presented. So we have k different beta values to be optimized. Today, we covered the classification and regression algorithms. We start with their definition and see their application examples. Classification and regression tasks are the main categories in this area. In our next video, we will cover another fundamental algorithm in supervised learning, which is k-nearest neighborhood. Thank you for watching our videos. If you have any questions, please do not hesitate to ask them in the comment below. See you in the next videos. Bye bye.